Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing numericals based on mole concept. These numericals are little tough. Okay. Now I will continue from the question number 252. Now I am reading the question. Keep pen and paper with you. Only then you can solve it. Okay. Now I am reading the question. How many molecules of an ideal gas are there in 1 ml of the gas if temperature is 27 degrees centigrade and pressure is 3 atm? First option 8.15 into 10 to the power 23. Second 8.15 into 10 to the power 20. Third 7.34 into 10 to the power 19. Fourth 7.34 into 10 to the power 22. Again one more time question I am telling you. Listen carefully. How many molecules of an ideal gas are there in 1 ml of the gas if temperature is 27 degrees centigrade and pressure is 3 atm? First option 8.15 into 10 to the power 23. Second 8.15 into 10 to the power 20. Third 7.34 into 10 to the power 19. Fourth 7.34 into 10 to the power 22. Just to think, you can solve it. Okay. Here you have to apply PV is equal to nRT. This formula you have to use. Here P is equal to 3 atm. Pressure. Volume is equal to 1 ml. Convert it in liter. 1 divided by 1000 means 0.01. Okay, 0.001. Then P into V you have written. N you have to calculate. R is equal to 0.081 liter atm. And temperature is 273 in Kelvin you have to convert. Then 273 plus 27 means 300. Now easily you can calculate the N. Then N will become, after solving, you will get N 12.2 into 10 to the power minus 5 mole. Okay, because out of 5 Pb is equal to nRT. Out of 5, 4 you are knowing, P you are knowing, B you are knowing. N you have to calculate, R is a fixed value and T is equal to given 300 K. Then N will become, after solving, 12.2 into 10 to the power 5 mole. But you have to calculate molecules, number of molecules according to the question. Then how will you calculate? Mole you have mole you are now knowing. Then in 1 mole, how many molecules will be there? Then Avogadro number. Then just to multiply 5 into Avogadro number, then that you will get number of molecules. Okay. Then 12.2 into 10 to the power minus 5 into Avogadro number means 6.02 into 10 to the power 23. That is the molecules. Then now this 10 to the power minus 5, this is 10 to the power 23. then 5 digit will go, we will get 9. This 20 out of 23, 5. It is 10 to the power minus 5. Then after solving, you will get 7 into 3, 4 into 10 to the power 19. Okay. Because 12.2 into 6, it will come 7.34. And this 10 to the power minus 5 and 10 to the power 23. Then after calculating, obviously it will be less than 23 because minus 5, that is 23. And this side after multiplication, 12.2 into 6.02, it will come finally 7.34 into 10 to the power 19 molecule. Hence correct option is option C. Third option is correct. 7.34 into 10 to the power 19. Now next question. If isotopic distribution of C12 and C14 is 98% and 2% respectively. If isotopic distribution of C12 and C14 is 98% and 2% respectively, then the number of C14 atoms in 12 gram of carbon is: first option 1.032 into 10 to the power 22, second option 3.01 into 10 to the power 22, third option 5.88 into 10 to the power 23, fourth option 6.023 into 10 to the power 23. One more time I am reading the question. If isotopic distribution of C12 and C14 is 98% and 2% respectively, then the number of C14 atoms in 12 gram of carbon is: first option 1.032 into 10 to the power 22, second 3.01 into 10 to the power 22, third option 5.88 into 10 to the power 23, fourth option 6.023 into 10 to the power 23. Just you think, only then you just think it, then I think you will be able to solve. Now I am giving you hint. C14 in 12 gram of carbon you have to calculate. Okay. Then here in question it is given if isotopic distribution of C12 and C14 is 98% and 2% respectively, then the number of C14 atoms in 12 gram carbon you have to calculate. C14 means which is 2%. Then C14 in 12 gram of carbon which is only 2%. Then in 100 2 gram is there. Okay, in 100 gram 2 gram is there. Then in 1, then in 12. Correct? In 100 gram 2 gram is present, C14. Then in 1, then in 12 gram. How much? Because you have to calculate in 12 gram. Then you will get 0.24 gram. Then this you got 0.24 gram mass you are knowing. Then in this how many atoms will be there? then a 0.24 gram you calculated. Then now this you convert into the mole by dividing it by 14. Correct? 14. 0.2 gram mass you are knowing. Now you convert in mole. Then 0.24 divided by 14. You got in mole. Then now mole you are knowing. Then in 1 mole Avogadro number. Then in this mole just simply you multiply. Means this here 0.24 divided by 14 into Avogadro number. Because in 1 mole 6.02 into 10 to the power 23 atoms. Then in 1 mole. Then in this mole 0.24 into 4 divided by 14. You multiply it. Then you will get, after solving, you will get 1.032 into 10 to the power 22 atoms. Okay, 1.032 into 10 to the power 22 atoms. Then correct option is first, option first, 1.032 into 10 to the power 22. Okay, this is the correct option. Now next question I am reading you. I am reading, just to listen carefully. If 0.22 gram of a substance when vaporized displaces 45 cc of air measured over water at 293 K and 755 mm pressure and aqueous tension is 17.4 mm, then gram molecular weight of the substance will be, first option 222.2 gram, second 232.3 gram, third 121.1 gram, fourth 127.5 gram. Again one more time I am reading the question. If 0.22 gram of a substance when vaporized displaced 45 cc of air measured over water at 293 Kelvin and 755 mm pressure and an aqueous tension is 17.4 mm, then gram molecular weight of the substance will be, first option 222.2 gram, second 232.3 gram, third 121.1 gram, fourth 127.5 gram. Okay. Now I think this question also you can solve it. Easily you can solve by using P1 V1 by T1, that is equal to P2 V2 by T2. Now see pressure P1 is given, but here in pressure this aqueous tension you have to reduce. That is the only important thing here. After that easily you can solve. Then from the pressure aqueous tension you reduce. Then you will get 755 minus 17.4, that is the pressure, and volume is 45 cc because it displaced 45 cc air. Correct? It means volume of 0.22 gram of substance was 45. Then now P1 V1 value you are knowing, divided by T1. Then here temperature will be how much? 293 it is given. Temperature 293 is given. Then P1, V1, T1. Now all three value you have written. That is equal to P2, B2, T2. Then now here for standard pressure, what is the standard pressure? 760 mm. that you know. Standard pressure is 760. Then you have to calculate the volume. Volume you don't know. First you have to calculate volume, then you will calculate gram molecular weight. Then volume first you calculate. Then 760 into V2 divided by standard temperature is 273. You are knowing. Then now volume you can calculate. Volume you will get, after calculation you will get volume that is equal to 40.7 cc. Then after that easily you can calculate gram molecular mass. How? Then this 40.7 cc, that is the volume. Correct? Then you know 22,400 cc is equal to 1 mole. Correct? 22,400 cc is equal to 1 mole. And now this you got 40.7 cc you got from 0.22 gram. Correct? 0.22 gram according to the question, its volume you have calculated 40.7. Then 40.7 cc, its mass is 0.22 gram. Then for 1 cc, then for 22,400 cc, you can calculate. That is a 121.1 gram. Correct? Because you calculated for 22,400. That is for 1 mole. Then 1 mole mass is called gram molecular weight. Gram molecular weight. Now you calculated 121. Okay, 40.7 cc, its mass is 0.22 gram. Then for 1, then for 22,400 cc, you will get 121.1 gram, 121.1 gram. Okay. Hence option, correct option is C, 121.1 gram. Now this next question. Next question. Now I am telling you. Next question, that is a question number 255. I am reading question now. A compound contains 2 oxygen atoms, 4 carbon atoms, and number of hydrogen atoms is double of carbon atom. The density of its vapor shall be. Again I am reading a question. If a compound contains 2 oxygen atoms, 4 carbon atoms, and a number of hydrogen atoms is double of carbon atoms, then density of its vapor shall be first 88, second 44, third 132, fourth 72. Again one more time question I am reading. Listen carefully. If a compound contains 2 oxygen atoms, 4 carbon atoms, and number of hydrogen atoms is double of carbon atoms. Here you have to understand. If a compound contains 2 oxygen atoms, 4 carbon atoms, and the number of hydrogen atom is double of carbon atoms, means 8. Correct? Number of carbon atom is 4. It means hydrogen will be double of carbon, means 8. I have explained you. Then you have to calculate the density of its vapor. What is the density of its vapor? You have to tell. First option is 88, second 44, third 132, fourth 72. Okay. Now, one more time I am reading the question, because question is a little, you have to understand only, then you can solve. If a compound contains 2 oxygen atoms, 4 carbon atoms, and number of hydrogen atoms is double of carbon atoms, the density of its vapor shall be first option 88, second 44, third 132, fourth 72. Okay, just to calculate, think. Here, this according to the question, compound is a C4H8O2, because this compound contains 2 oxygen, correct? Then and carbon is 4 and hydrogen is 8, correct? Then now it becomes C4H8O2 according to the question. You have not done anything. All thing is a given question. Oxygen is 2, carbon is 4, and hydrogen is 8. Then more compound will be C4H8O2. Then now its molecular mass easily you can calculate. 4 into 12 plus 8 plus 32. 32, correct? 12 into 4, 48. Plus 8 oxygen, hydrogen is there, then plus 8. Plus 2 oxygens are there, 2 into 16, 32. Then now that you can add it, you will get the molecular mass. 32 plus 8, 40. 32 plus 8, 40, and 40 plus 48, 48. Okay, 40 plus 48, how much? 88. 48 plus 8 plus 32. Then 8 plus 32 is 40, and then 40 plus 48, 88. Then now vapor density, you have to, it molecular weight you are knowing. Then vapor density, you know, formula is there. Vapor, that is the vapor density and this molecular weight, both are related. 2 into vapor density is equal to molecular weight. Then molecular weight is 88. Then 88 divided by 2, that is the vapor density. Formula is there, 2 into vapor density is equal to molecular weight. Then molecular weight you are knowing, 88. Then vapor density is equal to 88 divided by 2, that is the 44. This question was asked in AMU. Okay. One more question I want to discuss. Okay, 256. An oxide of a metal M contains 40% by mass of oxygen. Metal M has a relative mass of 24. The empirical formula of the oxide is first option M2O, second MO, third M2O3, fourth M2O4. One more time question I am reading. An oxide of a metal M contains 40% by mass of oxygen. Metal M, capital M. Metal M has a relative mass 24. The empirical formula of the oxide is first option M2O, second MO, third M2O3, fourth M3O4. You think you can solve it. This is oxide. An oxide of metal contains 40%. An oxide of metal M contains 40% by mass of oxygen. Now, just to think, you can solve it. See, element percentage you consider this 100%. Then metal is 60%, oxygen is 40% according to the question. An oxide of a metal M contains 40% by mass of oxygen. If suppose it is total is 100, then 40% is oxygen, 60% is metal. And you have to calculate the empirical formula, and metal relative mass is given. Metal has relative mass 24, it is given. Then now you can solve it easily. Metal is 60%, oxygen is 40%. And atomic mass of metal is given 24, oxygen you know 16. Then percentage atomic mass of metal how much? 60 divided by 24. You should divide by atomic mass. Then 60 divided by 24. You will get 2.5. This is the percentage atomic mass. Similarly, for oxygen, 40 divided by 16, 2.5. Hence, now ratio is, both are 2.5, 2.5. Then ratio is 1:1. Means empirical formula will be MO. Both are 1, 1. MO. Hence, correct option is B. Correct option is B. Okay, MO. Now, I am stopping only here. Next class, again I will continue. Thank you.